Hi, and welcome to the Mentored Engineer. In this video, I'm going to share with you this control box that I've built and tell you what I like about it and what I don't like about it, and just general guidelines for building control boxes. Okay, so this is a box I made out of wood. I had some scrap wood laying around. I do some woodworking on the side, so and I've made this box, and it has 8 input switches. And then 6 indicator lights, and that's just to simulate every input and output of my PLC. All right, you can see here that my cord comes out the side. I purposely did that because I didn't want it coming out of the bottom of the box, because I figured I'd be setting it up on its end. I recommend that you always bring your wires out of the bottom of the box, and in some exceptions the side, and that is simply for water. So once you drill holes in your boxes, no matter how good your seal is, you can still get water in that box. So if you put it in the top, you're probably going to end up having water collecting in the bottom of your box just from humidity and other things. You know, you open up the box, you can have leaks in the roof of the building, whatever. So highly recommend the sides and the bottom, just to prevent water from sitting on top of the box and getting in. All right, now this is the cable that I use to program the PLC, and as you can see, it's got an end on both sides, so it kind of makes it difficult to put this in here. But what you can do is you can get, let me open this up, you can get small boxes where you'd plug this in here, and then it would have a bulkhead here where you'd plug essentially the same port on each side, plug it into the box, and then there's another port on the other side, outside of the box, where you can plug in your cable. That way you never have to open the box to program it, which is a nice feature. Our switches here, you'll notice all of them here are blue in nature, except for this one. These are all just regular push buttons, and they're momentary. As soon as I push them, they will make contact. They will connect the two sides of the switch, and as soon as I release the switch, it goes back to being an open line. This one here, the E-stop, you're always going to want it to be a normally closed, and that's indicated by red for this particular switch manufacturer, a red color. And as long as the switch is out, it is making contact, sending energy through. So as soon as we would power up this box, you would see the input. All right. So, and then as soon as I press it, it would go away. And the reason we want to do this is we want to make sure that our E-stops are operational when we are doing our thing. And if I'm waiting for it to close the switch to say that it's off, that might be too late. Somebody's life may be at stake at that point. So we want to make sure that we're getting the signal, and we also should be checking them, you know, when we operate our machine, and making sure that each one works. All right, so one of the things about this box is it is not OSHA compliant. It's for my own use, so I'm not really concerned about it. So OSHA requires that any voltages over 24 volts be away from an operator. Okay, so this is 110 volts right here. This is a power supply, and my PLC is actually powered by 120 volts. So both of these should be in a box all by themselves if I want to work on this box while it's powered up. Now, generally speaking, other than this cable coming out, I don't need to be in this box. So I'm going to just allow it to be. However, I do have the width of this cable sticking out somewhere, so that is technically, you know, open. So if I wanted to be OSHA compliant, I would put this in another box and just run the 24 volt signal over to this box. And that box would also have a disconnect, or I'd be able to unplug it. This PLC would also need to switch to 24 volts. Now you notice here that the power supply and the PLC have protection over it, and that does not let you get around with it, get around that requirement. It is nice. I mean, it's harder to get in there. You know, you're not going to do that without without a tool or something, but you can do it. These are mostly just so I don't accidentally short across these things. So, you know, I've got 20 terminals here, so I don't want to be sorting that out. All right. The other thing I have in this box is 4 fuses, and they're kind of nice. They pull open like this. You can put a standard fuse in there like that. These are all 1/2 amp. This one here is fuses for my inputs. These 2 right here are fuses on my outputs. I have 2 commons on my outputs, so input 0, 1, and 2 are on this fuse, and 3, 4, and 5 are on this fuse. And this last fuse here protects my PLC power input. So let's talk about wires and wiring for a second. I have done a poor job at documenting this box. None of the wires are labeled. None of them are color coded. I have 2 pieces of Cat5 cable here, and there's no way to distinguish one from the other. You have to physically trace it. Now, this isn't a big box, and like I said, it's for my own personal private use. But in a real industrial setting, you're going to want to be able to troubleshoot this in the future, and you're going to want to have every one of these labels wired. There's several ways to do it. There are probably the best way is those that you print and heat shrink onto the wire. It's a permanent fixture of that wire, and it'll last as long as that wire does. The other ways are to get some sticker numbers, and you can put it on there. I recommend, rather than sticking it and wrapping it around the wire only, to actually have it so that you basically fold it in half over the wire, and it's got a little tab on it. You can actually, they'll actually stick to the wire better, especially if you've got any amount of grease on your hand or just oil, you know, just in fact sweat can be a major factor that the sticker will be sticking to itself rather than trying to stick around the wire. And then the last thing, I would always recommend that you have lots of wire duct. Wire duct is a 3-sided plastic strip, and it allows you to run wires in it, and then when you're done, you just put this lid on it. Man, it looks beautiful. So do that. And then one thing is about the door closing, the door panels. So this right here, we should be fixing that up against the box here so it doesn't move. We should also be fixing this end. Now I have this loop here. I'm going to close the box, and you can see that as I close it, this doesn't get pinched, it doesn't really move. That loop helps us to do that, and causes us to have long lifespans. Okay, so looking here at the front of it, I have just switches and indicator lights. This is kind of a very simple box. If you're going to put a HMI, like a touch screen, HMI is human machine interface. And those are touch screens usually that you'll have a screen, then you may have a couple of buttons on there that you can press rather than having all these. Those are all great. The one thing I would recommend is if you foresee 1, 2, 3, whatever, how many buttons being pressed a lot, you're going to want to have those separate actual functions, and it's just so you don't wear out that one spot on the touch screen. You know, if you're going to hit a button 4 times every time you do, you know, a cycle, it ain't going to last that long. You can also do things where you have numeric keypads and other things like that that are actually push buttons that are designed for higher use than an actual touchscreen. Okay, so other things I would change if I was doing this for a real metal box in a industrial application is I obviously wouldn't make it out of wood. All right, so my power cord here, it doesn't have a strain relief. All I've done is drilled a hole through the box and then put some electrical tape on the inside so that I can't pull it out any farther than this. And good enough for my box. It's just my own personal private box, so that's all I'm trying to do. But however, even if I wanted to do a strain relief, I have a 3/4 inch thick piece of wood here, and they don't make strain reliefs that go that big. You know, most boxes are 1/16 of an inch, maybe a little bit bigger as far as the sheet metal goes. So I just can't put a strain relief on that. Well, that's all I have for this episode. I appreciate you watching, and please subscribe to our Mentored Engineer channel. Thank you.